Okay, this video is how to do a titration, how to do the math to figure out the molarity. So remember, a titration is using a known concentration to find an unknown. So the first thing that you want to do is you want to write what the acid is and what the base is. So HCl plus NaOH. The reason that you need to do that is because you need to identify what these N numbers are right there, and I know there's no parentheses because there's only one, but if there was a number bigger than one, there would be parentheses. So we got to know what the n's are, because the titration equation that we're going to use is N MAVA equals N MBVB. Okay, now the next thing is I like to read the question again. So we got 50 milliliters of sodium hydroxide. So that's going to go with the sodium hydroxide. All right. With unknown molarity, that means we don't know the molarity of that base. Okay, is titrated with 3 molar HCl. So the 3 molar goes with the HCl. Okay, and it takes 25 milliliters of that. That also goes with the HCl. Okay, now what we can do then is we can plug in what we know. So N for HCl is just 1. So we could put it in there or just leave it out, whatever. If it's 1, you can just leave it out. Molarity acid, 3 molar. Okay, times the volume of the acid is 25 milliliters. That's going to equal the N for the base, but there's just one OH, so that's 1. Okay, times the molarity of the base, that's what we don't know, times the volume of the base, which is 50 milliliters. Okay, so then we're going to solve for molarity base by dividing by everything on the molarity base side. So we're going to divide this side by 50 times 1, which is 50. Okay, the milliliters cancel. Divide this side by 50 milliliters. Milliliters cancel. All right, and so if you do that, you're going to end up with the molarity of the base is going to be 1.5 molar. All right, so that's question number 1. Let's try another one. Okay, so this one we got phosphoric acid, so H3PO4, and we're going to titrate that with barium hydroxide, BaOH2. Okay, now if we read it, 50 milliliters of 2.5 molar, so that goes here, 50 milliliters, and it's 2.5 molar. Okay, is titrated with barium hydroxide. If it takes 35 milliliters of barium hydroxide, so that's right here with the barium hydroxide, what is the molarity of the barium hydroxide? So we're looking for the molarity of the base. So we would have our titration equation, N MAVA equals N MBVB. Okay, now when we plug in the n's this time, if you look at H3, so right here is our N, so we're going to put in a 3 there, times the molarity of the acid, 2.5 molar, times the volume of the acid, 50 milliliters. That's going to equal N for the base, that's a 2. We don't know the molarity of the base, I'm just going to write MB. The volume of the base is 35 milliliters. Okay, so what we're going to do is we're going to divide both sides to get MB by itself. So we're going to divide this side by 2 times 35 and divide this side by 2 times 35 because we want the 2 and the 35, and there would be a milliliter there, to go away. Milliliters cancel here. Okay, and so if you do that, you would get that the molarity of the base equals 5.4 molar. Okay, one more problem. Okay, sometimes you can start with grams instead of moles or molarity or concentration. So in this case, what they're doing is they're starting with 3.9 grams and they're dissolving it into some water to make a solution. And then they're titrating it with NaOH. So in this equation we have KHSO4, which again it says it's monoprotic. That means that the N is 1. Okay, plus NaOH. Okay, its N is also 1. Okay. Now the thing is, we need to know to do the equation, we need to know the N MAVA equals N MBVB. Okay, let's see what we know here. So we got 3.9 grams of this. 3.9 grams of the acid. Okay, but we're making 100 milliliters of it. Okay, and so we know that the volume of this, the volume of the acid is going to be 100 milliliters. All right, now that's titrated with the base. We're looking for the molarity of the base, and it's going to take 35 milliliters to get to the endpoint. Okay, now the problem is we don't have the molarity of this acid, but we have the grams and we have the volume. So what we can do is we can get the molarity by taking the moles. Oops, don't want that. We can take the moles divided by the liters. So to get the molarity. So to get the molarity, first we're going to have to figure out the moles, which if you take 3.9 grams KHSO4, you can change it to moles by using the molar mass. So 1 mole of that will equal about 136 grams. So that if you take 3.9, that's supposed to be a 9 there, times 1 divided by 136, you get about 0.028 moles. So then what you'll do is you'll plug in 0.028 moles, and you're going to divide that by, okay, we're doing 100 milliliters, but we got to change that to liters. So that's going to be 0.100 liters. So we end up getting the molarity of that to be about 0.28 molar. Okay, now what we can do is we can now go back to this equation and plug in our numbers. We know that that's 1. We just figured out the molarity is 0.28 molar. The volume of it is 100 milliliters. Okay, that's going to equal 1 for the base, times the molarity of the base, we don't know, times the volume is 35 milliliters. Now, one critical thing is if this is milliliters here, you got to make sure this volume here is milliliters. They have to be the same unit. Okay, now we're going to divide both sides by everything in the molarity base side, which would be 1 times 35, which will be 35 milliliters. Okay, we've got to divide both sides by that. And then what happens is we take 1 times 0.28 times 100 divided by 35, and that's going to end up giving you that the molarity of the base is going to equal 0.82 molar, I believe, if I did it right. 0.82 molar. Now, there's another way that you could do this problem. You could do it all with a picket fence, okay? But I think for now we'll just go with this way. If you prefer to do it with a picket fence type of problem, you would have to have a balanced chemical equation first, and basically this is kind of a tricky equation to write out. It depends how you write it, but it's best represented with a net ionic. But for now, I think it would be better if you just stick to doing it the way that I showed you there. Okay, that's it.